In example 11, an understanding of the term even-numbered terms is critical. What are even-numbered terms? Even-numbered terms are terms in a series that have even positions, meaning the second term, the fourth term, the sixth term, and the eighth term. In particular, you can take note, as indicated in the question, that the suffixes that represent the position of the terms are all even numbers, as highlighted here. So, in example 11, when the question says that t is the sum of the even number terms, we know that t means the second term at the fourth term, at the sixth term, at the eighth term, and so on and so forth. Because t is the sum to infinity of the even number terms, we know that there isn't a last term to the addition, and the second term being the u2 being the second term of the original geometric series with first term a and common ratio r, u2 should have the representation of a times r, since it's the second term of the original series. U subscript 4 is the fourth term of the original series with first term a and common ratio r, so u4 should be a r 4 minus 1, which is 3. Similarly, u subscript 6 will be a r power 5. U subscript 8, the eighth term, should be a r 7, and so on and so forth. Knowing that t is the sum to infinity, we know that t should be the a prime over 1 minus r prime, where we use the prime here to indicate the new first term and new common ratio of t. Well, then again, maybe it's clearer if I use the notation as a1 a subscript 1 over 1 minus r subscript 1 to denote different a and r compared to the original series. And the new a is actually the first term here, so the new a will be original ar, and the new common ratio is actually r squared, because we can observe from the series of t that from here to here we multiply by r squared, and from here to here we also multiply by r squared. So we will have this, that is t. Now, since we have obtained t in terms of a and r here, and the question says further that s is the sum to infinity of the series, meaning this in the solution, that s is a over 1 minus r, and the question says that s is 4 times the value of t, we can say that s equals to 4t. When we substitute the expression for s and t respectively, we will have this equation. when we divide both sides by a, on the left hand side we will get 1, and on the right hand side we will get 4r in the numerators. In addition, since r is not equals to 1, we know that 1 minus r is non-zero, and we can multiply both sides by 1 minus r. That leaves 1 on the left side, and on the right side we will have 4r over 1 plus r. Cross multiplying and simplifying, we get r equals to 1/3. So this example anchors on the meaning of even numbered terms. How about odd numbered terms? Odd numbered terms, as a side note here, you can guess that odd numbered terms will refer to the terms with odd positions, meaning the first term, the third term, the fifth term, the seventh term, and so on and so forth. So in future, when you see questions with such phrasing, you have to keep the definitions of even numbered terms and odd numbered terms in mind. Thank you.